Okay, so today we're going to be talking about multi-step equations. Some of it you've already seen. We tackled a couple in the last video. So I want you to follow the steps that are listed on the left-hand side. So step number 1 says distribute. So there's a half here in front. We're going to distribute that. So half times 40 is 20m. Plus a half times 10 is 5 is equal to 15. And then it says combine like terms on the same side. So that means 20m is equal to 15 minus 5. And then it says combine variables on opposite sides. So 20m is equal to 10. And then isolate the variables by adding or subtracting in constants. We don't have any of those here. And then last is multiply or divide by the coefficient. So m is equal to 10 divided by 20. So my final answer is m is equal to a half. Please leave it as a fraction. Don't convert it to a decimal. There's no need. So you'll notice sometimes I might have stuff in each step that I don't necessarily need to do in all of the questions. Sometimes it happens in all the questions, sometimes it doesn't. All right, in the next one, I don't have any distributing to do because there are no brackets. So I'm going to combine like terms on the same side of the equation. Well, I have 10y minus 12y minus 3y is equal to 5. And I can combine all the variables. So 10 minus 12 is minus 2. Minus 3 is minus 5y is equal to 5. Again, there are no adding or subtracting in the variables and the constants. So I'm simply going to say y is equal to 5 divided by negative 5. So y is equal to negative 1. All right. In this last one, we again now have some brackets. We have brackets on both sides. All right, so step number 1 is distribute. So 6 times 5c is 30c. 6 times negative 3 is negative 18 is equal to 3 times negative 4 is negative 12 plus 3 times 9c is 27c. Now it says combine like terms on the same side. All right, so I've got 30c minus 27c is equal to minus 12 plus 18. So it says combine all the things on each side. All right, so I've got 3c is equal to 6. And I've got c is equal to 6 divided by 3. So c is equal to 2. So again, you'll notice here that in each step, my step 1 was to distribute, step 2, combine like terms, and then basically step 3, 4, and 5 are isolate the variable. That's what that means. And then give your final answer. Now, there's sometimes when you look at a question, there's a couple ways to approach it at the beginning. Now, not everybody sees the same thing right away, but we all get to the same final answer because we're all doing this similar processes. So there's a couple ways to approach this question. The first way is to distribute a third into everything in the bracket, which is what we've been doing. So a third times 18 is 6, minus a third times minus 6x is minus 2x, and that's equal to negative 2. I've got minus 2x is equal to minus 2 minus 6. So minus 2x is minus 8. And x is minus 8 divided by negative 2. So x is 4. So that's a pretty good way to do it. I don't have an issue with that. In fact, many of you will do it that way because you got used to distributing whatever was in front of the bracket. Now, option number 2 is here I'm dividing by 3. So the opposite of dividing by 3 would be to multiply by 3. So if I did this, 18 minus 6x is negative 2 times 3. like this, and so I moved the 3 to the other side by performing the opposite operation. I could say 18 minus 6x is minus 6. Minus 6x is minus 6 minus 18. Minus 6x is minus 24. X is negative 24 divided by negative 6, which of course gives me 4. Both methods are great. Both methods have their, I guess, pros and cons. I think it's really about what your brain sees first. Now, looking at the next question, the major question is here, what about this second question looks different than the first one? So think about it for a moment, and then hopefully you notice that this lovely x is now in the denominator. So this might pose a problem for some people, but we're going to figure it out. So what looks different is that I have this x in the bottom. So again, I want to isolate for x. That's my goal, to get x by itself. So I'm going to subtract 4. So my best method of approach is 1 over x is equal to 10 minus 4. So 1 over x is equal to 6. Well, that's great. If 1 over x is 6, then what do you think x is? One way to think about it is I could write it as a fraction like this, 6 over 1. And then when I do that, I have a fraction equal to a fraction. So whenever I have a fraction equal to a fraction, I can perform this operation called cross multiplying. So 1 times 1 is 1, and 6 times x is 6x. And then I divide by 6 from both sides, so x is equal to 1 over 6. So notice from this step here to this step here, my x went from in the denominator, which is where it was, and it was kind of a problem sitting there, to the numerator. All right, let's give the next one a go. Well, here's my next one. Again, notice I have my x in the denominator here, but it's got some other stuff with it. It's got a 1 plus. So I got to keep it together as a unit. That's why I'm highlighting it. But I'm going to start this question the same way I started the last one. Hopefully, maybe you notice that I've got 22 over 1 plus x is equal to, and then I can write it as 11 over 1. This means, again, I have a fraction equal to a fraction. There's nothing else. So I'm going to cross multiply. So 22 times 1 is 22. I'm going to write it out, is equal to 11 times 1 plus x. Well, I've got some brackets here, so I guess the best thing to do is to distribute. So I've got 22 is equal to 11 plus 11x. I'm going to subtract 11, so I get 11 is equal to 11x. If I divide by 11, I get x is equal to 1. So again, whenever I have a fraction equal to a fraction, I'm going to cross multiply. Now, our last example for the day is slightly different. Here, notice I don't have a fraction equal to a fraction. I have a couple of fractions, and it's equal to another fraction. So this causes me some issues. So I can't do the same thing that I was just doing. So I've got to do something different. Well, because I have a fraction, my favorite thing to do with the fraction is find the lowest common denominator. And the lowest common denominator here between 3, 2, and 3 is 6. So what I'm going to do this time is I'm going to multiply each fraction. So there are 3. There's 1 here, 1 here, and 1 here. I'm going to multiply each fraction or each term by 6. So it's going to look something like this, and I'm going to write it all out. So I'm going to say 6 times 3x minus 2 over 3 minus 6 times x minus 1 over 2 is equal to 6 times 1 over 3. Okay, so when I do that, hopefully I notice I have the 6 multiplied by each fraction. Notice I put it in brackets, so it's very clear. Notice I wrote it out so that I wasn't smashing the numbers in somewhere in this over here like that. I think once you get a little bit of practice, then you can start to do that. But right now, I think it's a really good idea to write it out. When you do that, hopefully you see that I can reduce fractions. So look here. This 3 and this 6 reduce. This 2 and this 6 reduce. And this 3 and this 6 reduce. So this becomes 1 and this becomes 2. This becomes 1 and this becomes 3. And this becomes 1 and this becomes 2. Notice all of a sudden all my denominators are 1. Well, that's great because the entire point of multiplying by the lowest common denominator is to get rid of that fraction, the thing that's causing people anxiety. So my next line should read 2 times 3x minus 2 minus 3 times x minus 1 is equal to 2 times 1. Again, notice, because I multiplied by the lowest common denominator and everything worked out great, I no longer have any denominator. Now this question becomes a simple distribute, collect, and solve. So 6x minus 4 minus 3x plus 3. Maybe you didn't catch that, but I want to point it out right here because a negative times another negative gives me a positive, okay? I'm throwing that out there, negative times the negative, so when I do that, I'm going to get a positive 3 is equal to 2. So I've got 6x minus 3x is equal to 2 plus 4 minus 3. So 3x is 6 minus 3 is 3. So x is 1. I would say this is a pretty challenging question. I would say this is an awesome question for a quiz or a test because it really shows whether or not you understand the idea of what to do and when to do it. So keep that in mind, give the practice a try, and then we're going to move on next class with some more of these problems so that we can get a little bit more practice in. All right, see you soon, fellas.